Hello, everybody. Welcome back to a new topic of logic development. I welcome all those students who have joined for this particular course of logic development and also our students from the career course batch as well. I know some of you have watched the earlier videos of logic development, but believe me, this time around, the introduction could be the same, but the way we are going to take up this particular topic will be very different than what I had done in the last course or the last batch. I had shared the video recording of the logic development earlier with many of you. I hope you have watched it. It will definitely help you. But the way we are going to implement those things today or in this particular course will be more of interactive with using some tools which are fantastic, wherein you can visualize what you're trying to do, and that will build the confidence in you that you can code. Since some of you have joined for the first time, let me give you a short introduction about Impetus. Impetus was founded in 1999, and since then we are into training and certification programs for a variety of technologies. We are authorized partners for a number of technologies for Autodesk, for Oracle, for C++, for Python, for Tally, and a number of them. I'm Rishikesh, and I'll be conducting this particular course for you. I have 24 years plus experience when it comes to training, software development, and other business operations as well. I have been moderator at Purdue University, and I'm currently also adjunct professor at University of Pune for post-graduation courses. And teaching has been my passion. System programming, application development is area of my interest. I'm also Java certified professional, and today we plan to start off with introduction to program problem solving. Now, why this particular course? Many of you have met me. You had come down for the counseling. You're here, you met me with an expectation of learning Java or learning C++. But then I advised you, some of you believed, those who believed in me have here. Some of the candidates who had come down for counseling did not believe. I have seen a lot of young developers in a hurry to master technology. And believe me, what they end up doing, they learn a language. Now, while they only learn a language, they definitely understand the syntax of that language. But many of them fail to develop applications using that particular language. Not all, but many of them. Because even after they develop the language, they learn the language, when a problem statement is given to them, they fail to understand as to how to go ahead writing a solution or a code to solve that particular problem. If a code is there in front of them, most of the people, developers, can understand that particular code. But then at the student level or the freshers, where they fail is that to gain the confidence, I can solve this particular problem on my own. There is where the students fail, especially during the early stage of their career. But this early stage of the career is a formative year. Why? Because once you lose the confidence about your ability to write a program on your own, then how much ever training is imparted later, you actually run away from this career of software development. And you find some comfort in some area of IT industry where there is no coding that is required or where programming is not required. There are some qualities that you need to build to be a successful developer. And I'll push you very hard in this particular course so that you understand what are the qualities that you should have to be a successful developer. There will be some tasks which will be given, and you will be required to complete those tasks as well. And some of those tasks will be very simple. Some of the tasks will be complex. But when you apply yourself, it's not about getting the right answer or getting the wrong answer. That's not the very objective. How you apply yourself, that's something which is very important. Perseverance is one of the qualities. I'll be talking about qualities that you as a developer should have. Some time that I'll be spending on it. So, but what is the topic for today's discussion? It is just an introduction to this world of problem solving. Programming is all about providing solutions. It's all about innovations. It's all about a problem that has been identified by somebody in the market. And somebody comes with an idea and you bring that particular idea into reality by using the technology. So there is a problem and somebody thinks about an idea, but that idea has to be brought into reality. And for that idea to be brought into reality, you create a software, you create an application that bridges the gap between that problem and the idea that is there to overcome that particular problem that somebody is facing, market is. So if there is a problem that somewhere exists somewhere, solution to that particular problem is nothing but the idea that you have come up with. But what is more exciting is like you being in a position to come up with an idea and also building a solution to solve that particular problem. That means implementing that idea. So there are two stages: coming up with an idea, and once an idea, either it's your idea or somebody else's idea, your ability to implement that particular idea so that that solution can be put to use to solve some problem that the world is facing. Think about softwares which are very popular in the market today. MS Office is one such software which is very popular in the market. I believe each one of you must have used MS Office. Does it not make you more productive? Does it not enable you to create presentations very quickly, format your documents, do some complex calculation using Excel and other things? So it is addressing to some particular problem. Every problem solution that we have. You see Google Maps that we use. The navigation system that it provides is. Does it not solve the problem that we face while you are traveling? And so that maps are always there. From ages we have maps. But on that map, now when the tracking has been done for your vehicle, the way you move, that's an innovative way as to how the technology has been used to make life simpler, to enable increase in the productivity, solving some difficulties that the customer is facing. So softwares are going to be here for a very long time. You are thinking about making career in IT industry. That's the area where tremendous opportunities lies. Or you may be in any domain, you still need to know a bit of programming. And if you're into IT, you have to be very good in this particular domain. At the heart of all these technology-enabled services are those developers who build those solutions. Our objective is to make you one of those developers who provide solutions. Idea may be yours or idea may be somebody else's idea, but you being in a position to implement that idea and create a product on your own. So with that objective, we'll start with today's session. This particular topic is language neutral. Now, when I use the word language, I have nothing to do with your ability of say Pascal or C or C++ or Java or Python or Ruby or Scala. We don't care. This is all about you expressing your idea in a format in such a way, once that idea is clear, either you write the code based on that idea or somebody else writes the code based on that idea. It could act as a tool. You can provide an assurance to the other party that what you have thought is the right kind of way to solve that particular problem. Even before you touch your computer, you have to be very clear as to what are you going to do when you turn on your machine. Machine time is the most precious time. And I do not want you to waste the machine time, sitting in front of a machine, trying out something, and then that's not working. You one version, second version, third version, and then you give up saying, oh, I can't code. No, you're going to touch your machine only when you know what is that exact code that you're going to write. What is that exact thing that is expected out of you? So once that clarity is there, only then you're going to touch your keyboard. On laptop and the keyboard, not the music keyboard, your keyboard where you're going to type your code. So this coding is actually the most simplest part. The thinking about what to code is the most complex part. And then what you have thought, having an assurance about what you have thought is correct or not. How do you get that assurance? When you go ahead to your boss with some kind of idea, hey boss, this is what I plan to do. How do you give the boss the confidence that what you have thought is correct? So those are the tools that I'm going to provide you. using which you will have the confidence and you will instill confidence in your team members, your boss, your colleagues, your faculties, that what you're thinking will definitely achieve what you are expected to achieve. So with that note, let's begin. But there are some basic factors that one should know. It could be a repetition for those who have already watched my videos, but let it be so. Once we start with the activities, once we go ahead with this first introductory session, the things will be different. The first session would be a bit of a repetition for those this particular video earlier. But for those who are watching the video for the first time or attending the session for the first time, it could be all fresh. Many of you have done that logic development course earlier, but bear me for the first session because some of them are new and I need to repeat it. Because unless that basic discussion has not been done, there is no point in moving further. Okay, so let's begin. Before I begin, if anybody has any question, please ask. Anybody has any question? Anything that comes to your mind? Sanjay, Shashwat, turn on your cameras. Ankita. I need to see whether you're sleeping or you're aware.
There is actually issue with my camera.
Others? Shashwat has some difficulty. What happened to Ankita? Ankita, you need to respond. You all cannot be passive observers. चलो सर क्या कर रहे हैं, हम बैठे बैठे देखेंगे, सोते हुए देखेंगे. That cannot be. These sessions are more of interactive. There are a lot of questions which are being asked. Now, if you don't respond to my questions, then this learning doesn't make any sense. Are you putting in this particular time that you're going to invest, say next 20 hours you're going to invest with me to build the confidence of writing some very complex codes? So that this 20 hours will go waste if you don't interact. Whatever comes to your mind, you should talk to me, you could ask me, you could challenge me. We will discuss, because who knows, you may come with an idea which is far better than what I have thought about. There also exists such a possibility. Okay. So Sanjay, what's the problem with you? Camera on karat nahi.
Sir, थोड़ा late join.
Okay. Is my audio not clear? Viraj has just said that voice is breaking. Is that the case with others? Is
No,
the audio,
No.
audio is clear?
Yes.
Viraj, check at your end then. So, okay. Let's begin. Sanjay, you have put on a light which is right at your back. How will I watch? He is very smart. खुद के पीछे light लगा दिया, तो even if he sleeps, I cannot see his face. Light should be in front of you or it should be at your back. Very nice. Now I can see you. That's good enough. That's good enough. Smart ideas. Sir को देखना है तो देखो. Look at the flashlight. I haven't met Shreyash. Shreyash, we are meeting for the first time?
Yes, sir.
Okay. The rest, all of you I have met. I think Shreyash is the only guy who I have not met. Shreyash, can you quickly introduce yourself? What are you studying or you're working? What exactly it is?
Hello, sir. My name is Shreyas Ganpule. I'm studying in Symbiosis College, and I have taken the course of BTech CSIT Cybersecurity.
Hey, then we have met Shreyash.
Yes, sir. I have met you personally, but this is my first time joining the meet.
Said CS, the course. Then I remember you had come to the office, correct? Media office.
Yes, sir.
Okay, so we have met. Okay, let's begin with the discussion. Okay, language should not be any barrier. Anybody has an issue with the language, English? Okay. If there is anything that you want me to repeat, don't hesitate. Sayan is also meeting for the first time this week. Okay, jokes apart. Okay, So I hope you enjoyed your Tirupati trip, Saina. Video. Here we go. So let's begin with a very basic introduction. I don't see Harsh today. Can you check with him?
Okay, sir.
So, introduction to programming and problem solving. Our objective is to make you confident in this problem solving concept. Problem solving is about coming with an idea, solution. And solution should be such that it can be implemented on the computer, written in some programming language, and it can be executed by a machine. So that's our final objective. But before we begin, we all need to be aware of this particular concept called as computational thinking. This will help you a lot. And a lot of time people feel computational thinking means I need computers to be there with me. That's not the case. It's all about how you analyze a problem. When a problem comes in front of you, what's your approach that you take towards solving that particular problem? So how do you look at and analyze a problem is all about computational thinking. So it's not just about programming. A lot of people feel computational thinking means I need to write a code or something like that. It's not just about programming. It is your thought process. What do you mean by thought process? The way you tackle that particular problem. But now when you have to tackle the problem is you have to solve that particular problem. You have to come with a solution. Now, if you have to come with a solution, the solution should be such that it can be implemented by using some computer language. Otherwise, you come with such a fantastic idea which cannot be implemented. Now, that's of no use. Your idea should be such that you can implement that idea using all the tools, the techniques, or the concepts that we have in programming languages or in computer science, such a way that that idea that you have come up with can be executed on the machine. So it's an approach of solving the problem. It's the way you will analyze the problem. It's the way you will think about an idea, a solution to a given problem. But that solution should be such that you can express it using some computer programming language and you can execute that particular code on your machine. Now, when I use the word machine, I primarily mean the computer. Because if your idea is fantastic, but if you cannot implement it on or run it on the computer, then that idea is of no use for us. But computational thinking is not about you immediately start writing the code on your computer. No, but that idea should be in that format. So you have to come up with an idea. You have to express your idea in such a way that whoever knows converting that idea into a computer program, they should be in a position to convert that idea into computer program. So what you should do while you express your idea, while you're expressing your idea is nothing but the technique, the thought that comes to your mind as to how will I solve that particular problem. It's a logic. So the logic that you have should incorporate the concepts from computer science, the basic constructs which are present in computer science for solving any problem. Those are the basic constructs that we should use. Now, believe me, there are only 3 basic constructs that you have to master. You may be laughing, but now we have Sairam with us, who has been in the industry for a long time. And let me know, Sairam, if I'm right or wrong. When you write any code, any program, however small or however big it may be, it could be an as complex application like your navigation system that Google has created, or it could be as simple as addition of 2 numbers. Any problem solved, it is primarily made up of 3 basic constructs. One is sequence, second is selection, and third is iteration. Is it not the case, Sairam? Don't you have statements which come in sequence, then some conditional constructs, and then some iterative construct? So when you go right at the bottom of your code, you find these 3 basic constructs are being used.
Yes.
Okay. So if you master those 3 basic constructs, and then there are some high level constructs like functions and other things, which will organize these 3 basic constructs in different ways. So we can create a code which can be reused again. Okay, but then keep aside that concept of reusing the code, keep aside that higher level concept of functions aside. But when you are expressing your ideas, there are only three basic constructs that we actually focus on: sequence, selection, and iteration. Okay, our focus during this entire course of next 20-25 hours, whatever you spend, is to make you so comfortable that even if you do not know programming language today, if a problem is given to you, you should be confidently in a position to say, oh, I can solve this particular problem. So when you learn a programming language, what remains is the idea that you have come up with, the logic that you have come up with, just that logic needs to be translated into a format that your machine can understand, because you are designing that idea in such a way that it is such that it can be translated. Okay, although it may be in simple English, your machine may not understand English, but your approach is like computational. So you are thinking about those basic constructs which are available in programming languages, using which you can solve that particular problem. So it becomes easy for any other developer. You give that idea to a developer, the developer can also translate it into a computer program. You yourself can translate it into a computer program based on the language that you know. So our focus is on building your computational thinking ability. And for that, we'll take some exercises. Now, if you do, you don't have to be a computer scientist to think like a computer scientist. Okay, it's not like you spend 10 years and then you can start thinking. Computational thinking is about thinking in a systematic manner. You will not jump over certain steps. For every step, you will give a reason. Like, what do scientists do? They ask the questions and then they come with a solution. So they ask question and then they provide, what do you say, proof for the correctness of that particular hypothesis, correct? So we will also do it in the same fashion. If any statement that we write in our code, anywhere we write, we should be in a position to provide a justification. Why did we write it? Okay. And what was the reason why that statement appears at that place and no other place? So if you can justify every step that you have written and you don't assume anything, that's thinking like a scientist. So no assumptions to be made. And then everything that we do has to be given in minutest detail. If you follow this approach, and you have to have a justification as to why are you doing this task, why are you performing this particular operation. If you can justify every step, that is every instruction, every task, or everything that you have asked to do to solve that particular problem, if you can justify why is it required, why now, why not later, can I not do it in a different way? So if you challenge yourself, if you ask yourself those questions and you have a justification for that, you are a scientist. So scientists are people who have answers for things that they do. Right? Why is this done in this particular fashion? They will have some justification. There is this reason why I'm doing so and so, why this operation has been done today. So to be a computer scientist, for thinking like a computer scientist, you don't have to be a scientist. You have to have that attitude, a thinking process, which is more computational. So here, this computational thinking is a part of problem solving process that ends with writing a program, but then it starts with thinking out an idea. But ideas, you may think like, some of you may come, sir, I cannot come with an idea. A lot of people come up with me and tell me, sir, we don't understand what is to be done. We don't come with I find it difficult to come up with an idea. Okay. That's not the case. You have not been taught as to how to analyze a problem so that that idea will be generated. So idea doesn't come from somewhere. It doesn't require great IQ. These are any task. If you look at it, today we'll talk about concept of decomposition, pattern recognition. You'll realize what we will be learning over here, same thing can be reused to solve multiple problems. But that will happen with only those participants who actually solve even the simplest of the problems that I give you as a practice. If you solve, believe me, they will act as templates for you to solve even larger problems. You cannot skip that one smaller step and directly think, oh, when the most complex problem is given to me, then I will solve that problem. That doesn't happen. You have to start with small steps. But before you do that, you need to know how to approach a problem, how to develop a solution that the computer is capable of, and what the computer is capable of. So you can learn to solve a problem. It's not like you have to have that inherent ability. Your IQ should be such that you can come with an idea. No. With a systematic approach that you follow to solve a problem, you can actually come with a solution, and each one of you can come with a different solution. Okay, but there is a, what do you say, a proven, time-tested technique of analyzing a problem. So if you do the initial groundwork earlier, then automatically the solution will come up with. And how to do that is what we'll do with some set of exercises. How do you come with a right kind of solution to a problem? And if you follow the approach for every problem that you come across, be it programming problem or be it real life world problem, it will definitely help you. So this computational thinking will not just help you in solving problems that can be implemented on computers, it will help you to solve your day-to-day life problems also as well, because you're thinking in a systematic manner. And that is what we are here to do. So if you have this computational thinking, okay, following disposition or attitudes, confidence in dealing with complexity. And that's my responsibility, provided you do what I say. So how do you handle the complex situations? If you have that right thinking approach, most complex thing can appear simple for you. How? We'll be using concept of decomposition to handle that complexity. We'll use concept of abstraction to handle complexity. But how do you handle complexity? You should, for me, challenge is to make sure that you do not panic when you come across any complex problem in front of you. How to tackle a complex problem is what I'll teach you. Second is something which I cannot help you, but I can push you towards it. Persistence in working on difficult problems. There will be problems which are very difficult. There will be problems which you'll find it almost impossible to solve. But for you to be a successful developer, one trait or one attribute that you should have is that you will never give up. Till the boss doesn't kick you out of the office, you will not give up. You'll just keep on trying. Okay, that persistent in working with difficult problems. I know sometimes you try with different ideas and then you realize most of the ideas are not working. But then you should not put your hands up saying, "Mujhse nahi ho raha hai." That's a statement that you'll never make as a developer. I can get you people who have struggled, or even I have struggled with some implementations. And then if you just keep on thinking about it, you talk to your team members, you talk to your seniors, and definitely there is a solution that comes out of it. But you should not give up. The moment you say, "I can't do it, I'll give up, I'll do something else," then you are not a developer. A developer is somebody who will never give up. If the task has been assigned to you, till the time the task has not been solved, you will not look anywhere else. Tolerance for ambiguity. There will always be confusion. Things is not like the client will never give you things which are very well defined. So there will be confusion. So you have to have that tolerance for ambiguity. Where there is a confusion, you have to actually come with points saying, okay, this is what my solution will do and this is what it will not do, because this clarity I don't have. So there has to be some kind of tolerance for ambiguity. Confusion will be there. Some information may not be complete. So you have to seek for that information from the client. And ability to deal with open-ended problems. Open-ended problem is where everything is very nicely defined. Open-ended problem is like client is not a computer scientist. Client is not a computer programmer. So he doesn't define the problem the way you want to. He tells his own story. Client tells his own difficulty. It is for you to figure out what the client wants. Client at times cannot even express themselves correctly. It is your responsibility as a developer to identify what is the exact problem that the client is facing. Sometimes the problem is something else and client is telling you something else. So he cannot articulate the problem very well. Cannot articulate means, do you feel a businessman always will be very good in his language skills? Language is Marathi, Hindi, English, so that he can express himself very well. That may not happen. Rather, his team members may be reporting the things in a wrong fashion to him. For him, there is a problem. For him, he's facing some difficulty. And you have to provide you have to help him overcome that difficulty. The difficulty is the problem for him. And that problem is not very well expressed. It's open-ended. He says, my billing system does not work. Finished. Why it doesn't work, where exactly the things are going wrong, that the client will not help you. He'll say, my productivity is low. But then he only knows the end result. Arey, din mein itna kaam nahi ho raha hai. This is the end problem that I'm facing. But he doesn't know what is the cause of that problem. It is for you to identify what exactly is the cause of the problem. So you always have to think like a consultant. So whenever we reach your client, first have faith in yourself. Kya? I can feel like you are like the doctor for the patient. You have to have that confidence that I can treat that particular patient. Likewise, as a developer, you have to have that confidence. I can provide a solution to the problem that the client is facing. I can enable him to overcome the difficulty that he has. I can enable him to achieve the kind of productivity that he wants to achieve. So always put on that thinking cap. I am a consultant. Don't go over there, hey, what kind of problem will be there? Don't have that self-doubt. Will I be in a position to solve that particular problem? How difficult will that problem be? Go ahead confidently when you talk to your client. Yourself as a person who can provide solution for any damn problem that comes in front of you. Ability to communicate and work with others to achieve common goals or solution. Today's systems are very complex. Nobody knows everything. Okay. So we need to work in a team. Okay. Unless you are in a position to communicate with your co-workers, with your boss, with your juniors, believe me, you will never be in a position to develop a system. Currently, we have been thinking about some solution for one of our clients. And believe me, it's 3 months. We have been hunting for right kind of resources to build a team. Now that the team is ready, we can actually go ahead solving that particular problem. Because each person comes with a different expertise, and there is no one person who has all the expertise to solve that particular problem. So ability to communicate, understand what exactly is the requirement, and from where can I get that particular problem solved, that's very, very, very important. So you have to have the ability to communicate and work with others to achieve common goals and solutions. You alone in real world assignments from college work, you can definitely complete on your own. But real world problems, it will be next to impossible for you to create it on your own. For one of the new projects that we are taking up, believe me, where we are finding it difficult, it was not at a back end. We have some very good developers which are working with us. We have been facing problem with the front end, the screens that are to be created. The skill set is quite simple, but then that also requires expertise. Because at the end of the day, the client looks at the interface. Okay, your logic may be very good, but if a solution doesn't look nice, the client is taken off, correct? So we were like hunting for somebody who can create good UI, because we are good at backend, but functionally the code may be good, but it should also appear good. So different skill sets will be required. So you have to have a very clear idea as to what you want and how to achieve that particular thing. So you should be in a position to communicate the things very well to your clients. So computational thinking is what we will actually begin with. Okay. And once we have the clarity and approach we develop as to how to solve a problem, then we'll go ahead with some kind of exercises. So there are 4 pillars of computational thinking. So if you really want to build that approach, computational thinking is about approach, how to solve the problem. So these are 4 parts, 4 pillars that you should be very well aware of: decomposition, pattern recognition, algorithm, and abstraction. Rather, I'll say abstraction and then algorithm. So let's talk about slightly about 4 pillars of computational thinking: decomposition, pattern recognition, algorithms, and abstraction. And if you can master these 4 techniques, you'll be successful in this field of development. Okay, let's understand each one of them with some simple examples. What exactly do you mean by this? Decomposition is not a new term for you. You must have definitely come across this particular term called as decomposition at number of places. So what comes to your mind when you hear about this term called as decomposition? Bhageshri, what comes to your mind? You cannot, you turn on your mic, Bhagishree.
Yes, sir.
What comes to your mind when you hear this term called as decomposition? But it may be wrong, right? But what comes to your mind? What is the first thing that comes to your mind when you hear this term called as decomposition? You cannot hear you. Hold the mic near. Rahul, what comes to your
Yes,
mind?
sir.
What comes to your mind when you hear this term called as decomposition, Bhagishree?
Yep.
Rahul, what comes to your mind?
Sir, the breaking a problem into simpler tasks.
Breaking into simpler tasks. Okay, let's not talk about simpler, but breaking is definitely the case. So when a bigger problem has been given to us, we need to break down that bigger problem into several sub-problems. Because when you meet the client, you will be overwhelmed by the problem that he puts in front of you. So if you start thinking about the entire problem at one go, it would appear to be very, very difficult for you. So what we need to do? Decompose, divide and conquer. So what Britishers did in India, divide and conquer. You will divide the bigger task into several small tasks and then handle each of that small task. When all those small tasks have been solved, you can just organize them together to tackle a bigger problem. So decomposition is something that you need to master. It's a process of taking a complex problem and breaking into more manageable sub-problem. So decompose. Don't get bothered with the complexity of the problem that is there. We need to learn to handle complexity. The first way and the most basic first step that you should take towards handling complexity is divide a bigger problem into several small problems. So if somebody comes to you saying that, can you develop an ERP system for me? Now that's very difficult. So don't think about ERP at one go. What will that ERP have? Oh, it will have sales management. It will have employee management. It will have production management. It will have finance management, accounts management. So now one ERP has broken into 5 different parts. So now we can assign one task of sales management to one team. You can assign another task of production management to another team. You can assign another task of accounts management to another team. But if you assign the entire task to one team or one fellow, they will get lost. But if you decompose it, then that sales team or the developers who are working on sales, they don't have to bother about how accounts is working. They don't have to bother about how manufacturing is working. They can focus only on one subpart. So decompose. Within sales or within accounts, again, we can decompose it. So go on decomposing it to such a level that it becomes very, very simple for anybody to solve. So it's like breaking a bigger problem into several small problems or manageable sub-processes. Divide it. It's like divide and conquer is a strategy that we'll be using. Solving complex problem as a whole may seem very difficult. So I talked about ERP, enterprise resource planning. It could be very difficult. But if you divide it into several such problems, and then you club together all those things, like what I said, ERP develop karna hai. So I ask you to divide into sales, marketing, finance, accounts, production, okay, all these various parts. So when each of that subsystem is created, you can assemble them together to create a larger system. So this decomposition is something that you have to master. Problems are complex, world is complex, but don't make your world a complex thing. Decompose it to make it appear simple. The complexity never goes off. You have to manage complexity. If the problem is complex, it is complex. But how do you make it manageable? You make it manageable by dividing the complex problem into several small problems. So smaller complexity, and then divide them, solve each of that small problem. So when all the small problems are solved, you club the solutions together to handle that bigger complexity. So don't get worried about that complexity that you're facing. Always go ahead with decomposition that is there. Any questions regarding decomposition? Have you all understood what exactly this decomposition means?
Breaking into correct.
Yes, sir.
Yeah. Breaking into parts. So if you can break into parts, the problems are definitely manageable. Jayesh, have you understood? Give feedback. When you understand, say tick. If you don't understand, put a cross. So I immediately get a
Sure.
feedback. Yes, please.
Sir, but what if you have a smaller team and a bigger problem?
Then build a bigger team. Okay, there is no way. You either have to build a bigger team.
Everywhere this issue, sir.
Pardon?
Everywhere this issue, small team.
Everywhere, yeah, everywhere. So there are two solutions to it. Either get some more resources into the team, or second, you take more responsibility. If you're putting 8 hours a day, start putting 10 hours a day. There is no other way out. Because if that task requires that much efforts, either you will add one resource to share that efforts, or you put in more time to efforts will not be reduced. Utna to chahiye. Efforts hai, so that is required. So there is no immediate solution for it. Ankita, you have a problem? You haven't given a feedback?
No, sir.
Feedback though, click karo if you have understood. There is a reaction.
Okay, sir.
I insist of giving feedback because then I know you are listening to me. Yeah? Otherwise, I will find it difficult to know whether you are listening or not. Left. Either is there. Somebody else has left. So first pillar was decomposition. World is complex. Complexity will always be there. But the easiest way to handle complexity is to divide the complex problem into several sub-problems. If you can divide the complex problems into several sub-problems, handle each of that sub-problem individually, come with solutions, combine them together to build a larger system. That's the basic idea of composition. Second thing, second pillar of computational thinking is pattern recognition. What comes to your mind, Shreyash, when we say pattern recognition? What comes to
The
your mind?
similarities.
Similarities in? Correct. Similarities in?
Similarities in two objects which are related.
Okay. Similarities in the two objects which are related. Now let us put this thing, he's very nicely identified it. But now in terms of programming, in computational thinking, what happens is you have solved a problem today. Okay. And then you are facing another problem for another project, or within the project, somewhere else you're facing a problem. You have to have that ability to identify, is it similar to what problem I had faced earlier? If you can identify there is a repeating pattern, the task are something similar to it, then you can just apply your previous solution to this new problem as well, because you identified there is similarity, some part of it is common. Certain things are the same. If certain things are same, if you can identify the patterns, you're going to reduce your efforts. Because then what happens is, instead of you come with solution, every time you come with that similar problem, once you identify, hey, same thing I'm doing again and again. If you can, a similar kind of operation needs to be done over here as well. If you can identify that pattern, we can reuse your previous idea the next time. So identifying patterns is something which is very, very important. So pattern recognition. So it's programming is not about, oh, the problem has been given, I'll always start thinking about a solution. Think about, have you earlier solved the similar kind of problem? Identify if have you earlier done similar kind of operation on any data that you have come across previously. Then think about, how can I apply what I have done earlier to solve this new problem? If it cannot be the case, then you think about a new idea. But wherever it is possible, always try and identify the patterns which are existing. So if you can identify the patterns, you can speed up your development. Why am I saying speed up your development? Because you have some tested codes which are already there, certain things that you already done. So if you can see, a similar task has to be done, only here the things are slightly different. So make the small modification and use the techniques that you have already implemented. So pattern recognition is something which is very important. When we decompose a problem, we frequently find patterns among the sub-problem, similarities or shared characteristic. So Shreyash has correctly identified. There is some similarity. So when you divide a bigger problem into several small problems, you realize those small problems have certain things in common. Identify that commonalities. Identify what is common between them. And once you identify the commonality, then you can immediately solve it because you have done it earlier. So there's not a challenge for you to just do the same task again next time. So discovering the pattern makes the complex problem easier to solve, since we can use the same solution for each occurrence of the pattern. So whenever this kind of problem arises, I'm going to use the same thing. Say once you have done encoding of messages that are passed over the network, or once you have done encoding for the message for your login credentials when you accept from the username and password. So that encoding technique that you have learned, the same technique you can use tomorrow while you're exchanging any information with your client. Why just for username and password? So over the network, when you're sharing any information with your client, you had done encoding of the data, crypting, you had to use some cryptology kind of concept to encrypt the data, so that if some hacker gets the data on the wire while it is transmitted over the network, it will not make any sense to them. So why not use the same pattern like what WhatsApp does today? WhatsApp calls are very safe as compared to other calls because they are all encrypted. So if somebody gets into your network and gets a hold over the communication that's happening, even then that call will not make any sense for him. Why? Because it's encrypted. So if I have implemented an encryption idea for username and password, tomorrow I have to exchange some messages between the user. Why not use the same idea to make that communication safe over the network? So identify the pattern. So if I can identify pattern, then you can start thinking, where can I use that technique that I had learned earlier at other places? So think about applying what you have done earlier onto different areas. So try and always don't just be in a hurry. I have seen people, especially youngsters like you, moment the problem is given, they are in a hurry to touch the keyboard. Kab jaake main keyboard ko haath lagao, and when I start typing the code, they don't feel at peace till the time they do not start working on the computers. Hold on. Don't start writing the code immediately. Think, have I ever in the past come across similar problem? If I have come across similar problem, somewhat similar, can I extend the same idea over here? Identify that. That will enable you to speed up your development. That will reduce the chances of errors as well. This leads to opportunity to generalize an algorithm to solve many different problems that may look alike, like photo album on Facebook, data compression, and so on. Let's look at this. So you are creating a photo album on a Facebook, and there is one photo that you have, which is very large, that needs to be stored on the database server, because next time when you watch that particular video, you should be positioned to that video, or the image should get loaded immediately, as early as possible. Correct? It should not take long time to load. Even in a WhatsApp, when you post some photo, you must have realized the quality is reduced, but then that image can be loaded very quickly as compared to other places. It quickly gets loaded, transmission is less. So that compression happens and the data is stored on the server in the compressed fashion. Your Google Drive also goes on to store the data, or your Google Photos also compresses the images to make space for more images to be stored and so on. But then I take Kaustubh's photo and I had to store it. So we had applied the logic of compression and then we store it. Tomorrow, if I have some Kaustubh photo ki jagah, I have photo of Taj Mahal, that I also have to store. But I can apply the same logic that I used to compress the photo of my client. Same logic can be used to compress not just the photo, even if it's audio or even if it's video. I can think about applying that compression logic on audio, video. That logic can be applied. Some changes can be done. I can store that image data into the data server, and then I can quickly get that data back. So once you identify the pattern, try and think, how can I apply the same technique on different images that I come across, or different data which is having similar properties? Can I apply the same techniques over there to compress other type of data? When you send some messages, say there is a file that you are sending across the network. Listen, there is a file that you are sending across the network, a large file. It could be a song, it could be a video, it could be an audio, or it could also be your text file. Believe me, transmission over the network is like that every byte that is there in your file that needs to be transmitted in forms of bits over the network. The more the number of bits that are there, more amount of time it will take for transmission of data from one node, one point to another point on the network. But if I can compress it, say, look at these bytes which are there. So there were these 5 bytes, then 3 bytes, then 1 byte, then 2 bytes, then 1 byte, then 2 bytes, and then these are could be patterns of zeros and one, whatever it is there. And these bytes were to be transmitted over the network. But if you can identify a pattern, oh, there are 5 zeros, then were 3 ones, then again a 0, then again 2 ones. So what I could do, instead of passing 5 bytes, I could pass a counter saying 5 and the byte. So I have compressed the data. So instead of passing those 5 bytes, I am now passing, okay, I have 5 bits, then I have 3 bits, then I have 1 bit, then I have these 2 bits. And so you identify those patterns, what kind of bits you had. Create groups or specify, oh, there are repetition which is there. Here there is repetition. Then why pass those 3 bits past? Then there could be 500 times 0 which is there. Then why pass 500 zeros? Instead you can say, okay, 500 times 0 is appearing. So that we pass, the data will immediately get compressed. We learned techniques of compression. We had seen, those were there for career course, we had seen that encoding format, Hoffman encoding we had seen. Okay, that also was a concept of packaging or compressing the data. Others who are not aware, have a look at Hoffman's algorithm that is very commonly used for compressing the data. So when we have this data which is there, if I can compress for text, I could use the similar logic for some other technique data type as well. So compress the data, but वहाँ compress करते हैं क्या है? Pattern recognition. You identify, oh, there is some repeating patterns which are there. Same thing. So I'll tell you about images also. Images also we can do that. Suppose let's talk about some image. Let's take some photo. Let me just share a screen and let us randomly open some photo. Randomly, let's open some photo. Let's say some image that we take. I just say image. I just want some image. Here we go. And we take some image. Now, if it takes this particular image as well, okay, any random photo we could take. Okay, this is a random image that I'm taking. Let us increase this. Now tell me, watch it very carefully. This image will be broken into some pixels and other things. But if I look at this section of the data, don't you see almost the same color shade everywhere? Yes or no?
Yes.
Instead of passing these number of bits separately, so when you are creating a pattern, you could identify, okay, in this particular section, the same patterns are being repeatedly used. So I could specify what are the dimension and from which bit to which bit, same, or let's say it is divided into number of lines. So if I go ahead with this line over here, where I am right now, there you will also find the same color shade is there. So why pass that many number of bits to specify that shade of colors? Okay, because if I expand this image to a larger extent, you'll this is not getting expanded too much. You'll realize it's made of those pixels. Now, if it's made of those pixels, then the same set of pixels will appear in a sequence. Then why pass that many number of pixels? Can't we say this color shade pixel appears these many number of times? Yes or no? So the same compression technique, what we could use with text, we could probably use the same technique even with images. So identify the pattern. Once you identify the pattern, apply it. Say you understood that particular pattern, you had applied on the text. Why not apply the similar kind of pattern even on images? Apply it on images as well. And once you have applied on images, then you will have a confidence. Okay, if any kind of compression has to be done, I can use this particular technique and I can apply that compression techniques whenever and wherever required. So pattern recognition is also something which is very important. The first was decomposition. Second is recognizing pattern. Now, I gave you example of image and we talked about text and photos, but it could be about a task as well. That means while you are solving a problem, within that particular problem, you will come across operations which are very similar. Or the task that operation that you are trying to do on the data that is very similar. Or similar kind of operation has to be done some other data as well. Don't waste your time writing the code again. Use the same technique that you had used earlier to operate on the transform the data again. So identify the pattern and save your efforts. Understood this pattern recognition? Any query, anybody? Quick feedback. Quick query है तो पूछो. If you still feel it's difficult, नहीं समझ में आ रहा है sir. If you have any doubt, please ask. Please don't hesitate to ask. Kaustu, Monica, Ankita.
Sir, that library we created, it was example of this only, no? Pattern recognition.
Yeah, but we created a library and we did not apply it on different situations, correct? But then in a problem, you'll come across a situation where you have to think, oh, I can use that thing that I have in the library. Right? So if you can think, oh, I have that solution in the library, which I can reuse, then that is applying that particular library. We only created library, we did not put it to use. Are you getting my point?
Yes, sir.
So we should be in a position to put that library concept to use. But then when we'll use it, say you understood, suppose in that library we had written a code to find square root of a number, suppose. Then tomorrow in some logic that square root has to be calculated. Don't write the code again. Use that thing, that part from the library, get that work done and proceed further. Okay. So when you decompose your problem, apply, identify if there is anything which is a repetitive task and avoid repetition. Avoid repetition by using the techniques or things that you have already developed. Apply those things again. So it's more like reusing what you have or modifying the things that you already have to address to a new issue, new problem that you have. So apply, identify the patterns and apply the techniques that you have already mastered to solve that particular problem. Is that okay? Any query, anybody? Okay. So two pillars we have covered up, decomposition and pattern recognition. The third one is equally important, and that is data representation and abstraction. So data representation and abstraction involves determining what characteristics of the problem are important and filtering those that are not. Very, very important. This term abstraction is misunderstood, misinterpreted everywhere. So we have to have very clear idea as to what abstraction is. Abstraction is focusing on what we need and ignoring those aspects that we don't need. Listen to me very carefully. Focusing on those aspects, those features that are relevant. Relevant what? They are required so that the solution of the problem can be complete. Let's take an example. Listen to me first. Let's take an example. I do this in object and concept as well, but let's do that exercise over here so that you understand what exactly the abstraction is. You have a data in front of you. Okay. We have to build a system. So you have to represent the data in the computer system. Listen to me very carefully. So I said data representation and abstraction. Why am I saying that? If you expect your computers to solve some problem, that problem may, whatever things exist, they need to be represented in your computer. Say you are doing a shopping cart billing system you are creating. So those items which are present in your store, the invoices, the bills, everything should be representable in your machine, computer man. So there are objects, you may have a soap or some perfume, or there could be any toiletry item that is there, whatever it is there. They need to be represented in your computer. Now in your computer, you're not going to store the soap and the bottles and everything. You're not going to store in your computer. So you'll have representation of that particular object in your computer. Means what? You have that item, the name of the item, the description of the item, the price of the item, and so on. So those are the characteristics of that item. Listen to it very carefully. The real world thing exists in the real world. A representation of the real thing exists in the computer system. Your machine never stores the item. It stores information about the item. Have you ever seen a computer which stores students? Have you ever seen a computer system which stores the entire bill? They store the information that is there inside the bill. They store information about the student. They store information about the products. Does your computer store the actual product? Yes or no? When Tata's manufacture car, does the computer store the car, or it stores information of the car that they have manufactured? Information. Correct. So it's representation of the data. But now, when you talk about representation of the data, how do you represent the data in the computer system? That's very important. Okay, let's take this example and let me see whether you can guess it right. Through data representation, we can create a representation of what we are trying to solve. So any problem that is there in front of you, we want to represent the things which are involved in that particular problem, in the solution to the problem, in the computer system. We have to represent those things. Like online retail website that sells Kindle book like Amazon and think about what information important to represent for a catalog entry. Now you give me an answer for this, because all of you have come across a site like Amazon where you have seen the Kindle books which are there, all the books which are there. Now there is an online catalog that is there. Now you tell me what information about that book, it could be Kindle, it could be any book, that is stored on the Amazon site or that needs to be stored about the book in that Amazon site. So if I go to Amazon, if I take you to Amazon books, if I go to Amazon books, and you'll always find those lots of books which are there, correct? Lots of books which are there. Even before we look at this site, now you all guess and tell me what information. Don't open up Amazon site right now. Don't do that. No cheating. Huh? Now you all tell me what is the information that we need to store about that book in an online catalog. So if I have an online catalog that I'm creating, what information do we need to capture about that book?
Book
Title and
name.
author.
One at a time.
Summary, author.
Ek minute, who is answering? Raise your hand and answer. Raise your hand. Okay, Bhagishri. When I say raise your hand, you have to raise your hand on Zoom. Huh? Because okay, so Zoom में आपके पास एक raise hand option है, so that I can immediately understand because there is everybody's image does not fit. Huh? So Sanjay has raised a hand. Sanjay, tell me.
Book title, book author.
One item. Book title and author. Rohit.
Book summary.
Book summary. Okay. Bhagyashree.
Price of book.
Price of book. Okay. Come on, others.
Rating.
Louder.
Rating.
Rating of the book.
Reviews
Okay. Louder.
reviews or rating.
Reviews of the book. Okay. Sairam.
Number of pages.
Number of pages. Viraj.
Sir, content in short.
In short. Okay. Come on, everybody has to tell. Aditya, what do you feel needs to be captured? What info-
Sir, reviews and rating and
Okay,
reference pages like
we didn't hear the last part. Reference. What did you say?
sir, 1 or 2 pages of that book, particular book.
1 or 2 pages of the book. Shreyash.
Price of the book.
Price of the book. Okay. Prithviraj.
Summary.
Summary of the book. Okay. Then Ankita.
Sir, apart from the summary, it should be mentioned that why we should, buy the book and what is so special about the book.
Why we should buy the book, what is so special about the book, and so on. Okay. Now, just think about from Amazon's point of view. Amazon is a platform where they want to sell that particular book. They have nothing to do with that book. They are more into selling than doing anything else. So, उनका major objective क्या है? Selling. Are they really interested in promoting education or promoting that author or anything else? The major objective to them is to sell that particular book. Correct? Have you all not forgotten when very important property, that's the cover page of the book? Don't you normally look at the cover page, how that book appears? Without the cover page, only the details of the book. Have you ever gone into even making a decision about purchasing a book when that cover page of the book has not been shown? You always look at cover page, yes or no? Tell me.
Yes, sir.
There is no
Yes,
image of the
yes,
book
sir.
and you think of purchasing that book. That is it. Does it happen?
No.
No.
No. So cover page was something which is important.
Yes, sir.
You are not going to purchase that cover page, but that was going to influence your decision to purchase that book.
Yes, sir.
Right? There are a lot of other properties. Who is the author? What is the credibility of the author? How many other books that author has written? There is so many other information that we could give. There's so much of other information that we could give. But from the point of view of Amazon, who wants to sell that book, you'll only focus on those aspects which are more important from the perspective of selling that particular book than anything else. Because it's a selling platform, sell and purchase platform. Correct? So there are a lot of things. Somebody said summary of the book. Okay, that's a very good idea if you're really serious, but Amazon does not give you the summary of the book. Okay, it could give a brief abstract as to what the category that it belongs to, will not give you a detailed summary of that book, which can, say 1,000 pages book, a summary could be at least 10 pages. They hardly give you summary of that particular book. Okay, but they highlight upon other aspects. What are the different modes in which you can buy? वो hard cover है या soft copy है? Yes or no? Hardcover books will be purchased in a different rate. Soft copy books will be a different rate. Old books will be a different rate. Correct? So whether the book is new, old, what kind of edition it is. Okay, the latest edition would like to have, or the older edition would like to have edition of the book. Don't you look into those edition when you purchase that book? Or I'll give you an edition of 1990 ka ek edition deta hu book ka. Will you purchase the edition of the book which is older when there is a new edition printed this year?
No,
New
sir.
edition.
Is definitely if it's at the same cost. So let's go to this Amazon site and see what have they done. Okay, what have they done? So if you come to this Amazon site and look at this book that is there, Lifetime of Malala Yousafzai, the Nobel laureate who is there. Who, author name, when was it published, what is it rating, okay, what is the rating, hardcover hai, soft copy nahi hai book ka, hardcover hai, price kya hai, and when can you get it? Is that book available in the store or not? Now you give everything, summary, everything, and that book is not there in the store. Book is not currently available. Was that book of use to you? So whether the book is there in the store or not, how much time will it, whether it is delivery free hai ya nahi hai, how much time will it take for the delivery? Those things were very important. It's a bestseller book or not, because this is bestseller, this is not. Even if I want to click on this particular book, that was a sponsored book, suppose, then what do you have? Okay, it tells you about a Kindle edition hai, hardcover ka price kya hai, okay, a author hai, how much you're gonna save, is EMI available or not? You're more concerned about what do you say, promoting that book, and they are more concerned about selling the book. So they are talking about EMI hai is book pe, you can purchase it with some EMI. There are 3 offers which are there. If you buy this book in some bundle, 10 days ka replacement hai, delivery Amazon se milega aapko. So think about, and this was the brief that was given. Bas, why would somebody said that, why would somebody go on to purchase this particular book? Okay, and then hardcover kitne pages ka hai, kaun se language mein hai, ISBN number kya hai, dimensions of the book kya hai, okay, who is the packer of that book, what kind of category does it belong to, okay, so bestseller when kya tha. So look at the information, and but the most important information that they have put across over here is kya hai, no cost EMI is available, bank offers are available, okay, कब रिलीज हुआ है बुक, कब का एडिशन है बुक का, हार्ड कवर है या सॉफ्ट कॉपी है, ओके. सो लुक एट द थिंग्स दैट यू आर ट्राइंग टू आइडेंटिफाई. द हार्ड कवर, अगर आपने सिर्फ मलाला यूसुफजई पढ़ा होता, probably I couldn't have identified, but when I look at her face, I could identify, I know this girl, she was brave enough to face the Taliban, and she was shot in her head, and still she survived, and she still wanted to go to the school or whatever it is. Okay, let's we recently Shahid Divas we had. The life of Bhagat Singh. Think about a book where no picture has been given, no details have been given about that particular book. Okay, you would rather not go ahead purchasing that book. Hardcover 14 January 2022 ka hai, author kaun hai, ratings kya hai. Okay, there are some images which are there about that particular book. The day when who is the publisher of that particular book, so we can follow him, and so on. How will it appear? The details about that author, what research has he done. So whenever a problem statement has been given, see to it, capture only that information which is relevant. Never think about capturing all the information. Let's take another example to understand this aspect. Say I'm creating a student management system for a college. For a college, we are creating a student management system. One of the most important object that will be present inside the college management system is student, because without student there will not be any college. Right? Every student has some information about, but are we going to capture all the information of the student, or only thing which is important from the student management system as far as the college goes? Let's take example. Now, what information would you capture about a student, about a person who is a student in a college? Now, whatever may be the age, I can also go and join a college tomorrow, correct? I may be almost double the age of yours, but I can also enroll for the same course, what you have enrolled for anywhere, correct? So what information would you capture about a student? Come on, everybody will tell me one piece of information. Rohit?
Number.
What?
Mobile number.
Mobile number. Bhagyashree?
Of student. Name of
Name
student.
of the student. Sanjay?
बैकग्राउंड मतलब लास्ट टाइम रिपीट कौन सी डिग्री थी?
Okay, highest qualification. What qualification? you had? Okay, Aditya.
Sir, maybe the branch in which he is studying and roll
Branch
number
you
and
studying.
etc.
Okay, branch you studying. Okay, so you are only thinking on from a perspective that he's an engineering student, so he'll have some branch kind of thing. Okay, Rahul,
Sir, the identity, Aadhaar card.
Aadhaar card. Sairam,
Roll number.
Raj,
Sir, parent details, family
Pa-
details.
family details. Prithviraj,
Address.
Shreyash,
The year which he is studying in.
year which is studying. Kaustubh,
Sir, photo.
photo. Ashish,
Fees pending, result, attendance.
okay, result, attendance, fees pending. Okay, Ankita,
Sir, email ID.
email ID. And Monica,
Sir, his personal details. Like, sir, it also his
give me
caste,
one.
something. His
His
caste, sir.
caste. Okay, now look at this. Monica has identified one detail like his caste. I could tell about his height. Is the height information of the student? Every student has this information called as height. He will have some height property here. Yes or no? He'll have some weight.
Yes.
Right? There will be some caste that he belongs to. In India, there is a caste. There will be some caste. He will have blood group.
Yes.
Correct? Then he may be vegetarian or he may be non-vegetarian.
Yes.
But do you really want to capture all this information?
No, sir.
Is it not the information pertaining to the student? His weight does not belong to him. Height doesn't belong to him. His caste doesn't belong to him. His color complexion doesn't belong to him. Like every student has a name, so every student also has a weight.
Yes.
He has a height, he has a color, he has a caste. But do you really feel that was important from the college management system perspective or the course management system? Do we really need to have this piece of information? Whether he's a vegetarian or non-vegetarian? So vegetarian to another set of examples, assignments. Non-veg hai to another set of assignments. We has to teach a person who eats non-veg in a different way. Person who has a vegetarian preferences will teach in a different way. Is that really the information that we would like to capture?
No, sir.
Definitely not. Correct. So information was about the student, but what are we trying to capture? Only that thing which is relevant, and we are ignoring the rest. Whereas rest all information also belong to the same student, but we are ignoring the things. Regarding the book also, there could be a lot of other things which are there. The quality of the paper, that's about the book. Okay, but we are really not interested right now in that quality of paper. So although that information belongs to that particular book, but we are still ignoring. Where was that book printed? Array, where is it published? That printed? Abhi kya kaun se press mein print kiya tha? That book definitely must have been printed in some press. That information you will have inside the book. Where is it printed? If you look at that, they always mention printed by or whatever it is. Okay, but are we really interested in showing that thing on Amazon site? Where was that book printed? Was it anyway going to influence the person's decision to purchase that book? Or the student caste, is it always necessary for you to capture that particular information? Or the food habits of the student, was it always necessary for you to capture that piece of information?
No.
No. So there is a lot of information because everything that exists in the real world has to be represented in your computer system in form of information. So anything that is there in the real world, when I say that has been represented in my computer system, it's only the information about that thing that you store in your computer system. So you have to be very careful as to what information you store and what you ignore. Abstraction is about you identifying what is relevant and what is not relevant. Correct? So any person's information, what I'm trying to store. So what was the relevant, what was irrelevant over there?
Height.
Height was irrelevant. Then
Vegetarian or non-vegetarian.
listen to what I'm saying. Any person's information, if I'm trying to store, what is irrelevant?
Color
Height,
complexity.
weight, color complexity.
Hold on.
Anything which
Sanjay.
is not useful for that college or
Now look, Kaustubh has made an important point. Anything that was not useful for the college. So context is very important. So that student was represented in the college. Now think about it. I intentionally said, what was the information of the person that I would like to store? And Sanjay said, uska height, uska weight, uska color was not important. But agar wo college hai to not important hai. If it's a matrimonial site, if I have to wed my daughter to you, or if I have to get that girl as a wife of my son, in that case, would I not look at her height, weight, color, her caste? In India, we always look at a caste as it, although we should not be. But then, would you not give a consideration to the height and weight? She is 6 feet tall, and my son is 4 feet tall. Chalega? How will it look? So, if it was a matrimonial site where that person's information was captured, then we will not be interested in the roll number. Uska college mein roll number kya tha, uske percentage kitne the, what is the last degree that he had. So we will be more interested in what's his earning. Okay, we will be more interested in knowing what is color complexion, if not the exact color shade, but at least color complexion, his height, his blood group. Wouldn't we not be interested? So if the context changes, the problems is different, the information about the same person is different. See, Viraj ki jankari hai. Viraj, when represent the college system, will capture another information. Viraj, when represented on the matrimonial site, information that will put on matrimonial site is different. Na? Or in matrimonial site, you will say, I know C++, I know Java, I know Python. And you want to marry me? So if you want to marry me, you should know C++. Then we will marry. Aisa karoge, Viraj? Will you put your technical skills over there? But if when you're applying for a job, would you write food habits? I'm a smoker. I prefer non-veg. That is what you write in a resume that you give to your company where you are applying for a job. There also abstraction comes in because your resume is your representation that the interviewer will be looking at. Will you write your food preferences? My favorite hero, my favorite dishes. Will you mention that over there?
No.
Definitely not. Definitely not. Your weight kabhi dala hai kisi ne resume pe? I weigh 80 kgs, I weigh 910 kgs. No. Look at the thing. The context changes, the information changes. It's of the same person. The abstraction is extracting, identifying what is the information that we'd like to store about that particular thing based on the context where it is to be used. So context is something which is very important. So everything that exists in the real world needs to be represented in your computer system in form of information. Now tell me, is it not true? Anything that is there will always be stored in the computer system in form of information. Now, if that information is being stored, what information is being stored is very, very important depending on what is the purpose, what role that particular thing is going to play in that system. So you always need to understand the context in which we are working and then capture the information which is relevant. Ignore the things which are not relevant. Not that weight is not important, not that height is not important, not your food habits are not important. They are important, but not when you're learning the particular course. Correct? They are very important when you're trying to marry somebody. Your blood group should be very clearly mentioned in your marriage profile. Why? Because people with the partners with same blood group may face issues. It is important to check not your the patrika that we check. It's more important to check your blood group, whether blood group is same or not. It's preferable that your blood groups of husband and wife are different. They shouldn't be same if possible, wherever possible. They're having the same blood group. Rather than checking Manga hai ka, hai ka, te hai ka, rather than that, you should rather check the blood group. Okay, so capturing information which is relevant is something which is very important. So what is data abstraction? Saira, Shreyash, can you explain what is data abstraction?
So extracting the information that is relevant based on the context.
Perfect. Capturing, सिर्फ extract करके छोड़ नहीं दोगे, extract करके capture करोगे. So instead of using extracting, I'll say capturing, identifying. So you are going to identify what is the information that you need. And at the same time, if you identify what is that you need, haven't you identified what is not required? What is to be ignored? So abstraction is about both things. What needs to be taken into consideration and what needs to be ignored. And you have to have strong reason for it. Why did I not take that information? And why did I take this information? When I'm trying to put across my information on a matrimonial site, why did I give this information? There should be a reason for it. And why did I not give the other information? There should be a reason for it. When I'm representing a student in a college system, you should be very clear. Why didn't I take his height and weight? Because that's not required in any college operations probably. Probably. If there was a justification, height is required for the college to decide which sports activity can you be indulgent to, then I would rather capture height as well. Yes or no?
Yes, sir.
The context and deciding, identifying what is relevant and what is not relevant is something very important. So abstraction is very important. Otherwise, what happens is, I'll tell you, people try and create systems which are very complex. They try and capture every information that is there. And that's waste of time, waste of efforts if you try and capture information which is not required. So same object, same thing is represented differently in different system, depending upon what is the purpose of existence of that thing in that system. The student when in college and student in matrimonial site, the perspective is something different. The objective of the student being in college and objective of student being on a matrimonial site. Student can also marry. It's not like age is a barrier. Okay. So what information that you capture over there, you try and use to represent the student will be different at different places. So abstraction is another pillar of computational thinking. Identify what is relevant and ignore what is not relevant. It is there. We know information is there, but ignore. Intentionally ignore, because we know that unnecessary information that you will take will not be of any use or will not be playing any role while you design a solution. So that information which is not required should not be captured. Not required means which does not have to play, doesn't play any role in the solution to the problem. Why should we take that information? Ignore that piece of information. So don't go after capturing everything. Capture only things which are relevant. Have you understood this, everybody? Abstraction?
Yes.
And I hope this goes beyond your book definition. Ankita, it was the same question that I had asked you last time.
Yes, sir.
Have you got the clarity about it? Do you agree
Yes,
to what
sir.
I say?
Yes, sir.
Sir,
Yes, please.
sir, is this definition also applied to OOPS concept in?
Of course, it's an approach. OOPS concept is nothing but way of analyzing problem. That's what we are discussing. Look, I'm going to take you about different techniques of analyzing a problem. OOPS is one of the most powerful concept that is used. OOPS means, those who are new to programming, is talking about object-oriented programming. One of the foundational stone of object programming is abstraction, data abstraction. But there, वहाँ और भी कुछ आएगा, वहाँ functional abstraction भी आएगा. Currently, I'm just talking about data abstraction. It's a foundational stone.
So it has subtypes.
और भी है. There is more to it. This is just an introduction. In logic, if I start talking about all the details, but then remember what I said. This particular course about logic development is about giving you an overall idea. It's not about a specific technique. As I go ahead with this, I'll be giving you a note where I'll tell you 7 different techniques of analyzing a problem, but we'll only touch upon it. Has anybody of you heard about HDLC? Sanjay? Rohit? Rohit, आपके syllabus में है HDLC. Software engineering subject है कि नहीं है?
Last sem log.
Last में के दिन ही होला. How is that? Okay. And I know for sure, Sairam may be using one. Sairam, are you using Agile in your company?
Yes, sir.
Are you using Scrum in your company?
For namesake.
But you're using.
Yes.
You're using, correct? So I'm also going to touch upon those things. But that does not mean I'll make you a Scrum Master immediately in a 1 day or 2. Scrum Master is a different course altogether, correct? But we'll touch upon those areas as well. So that you have an understanding as to what are the approaches which are there. Computational thinking is an approach as to how to analyze a problem. Object-oriented technique is one of the very advanced techniques as to how to analyze a problem. So that is precisely what we are trying to understand. Different techniques. So 3 pillars we have covered. What is remaining?
Algorithms.
Algorithms. And we are all in a hurry to jump onto algorithms and writing problems. Okay. We don't even think about algorithm. We actually are in a hurry to write programs based on it. Okay. Abstraction. Figuring out what characteristics of the problem are important and using this using this to represent to create a representation of the problem to be solved. So only capture those characteristics, those properties which are relevant, and ignore the rest. Unimportant characteristics can be filtered out and ignored. And the last one is algorithm. What do you mean by algorithm? Algorithm set of step-by-step instruction of as to how to solve the problem. So whenever a problem has to be solved, you'll follow this instruction one after another. I'll do this, then I'll do this, then I'll do this, then I'll do this, then I'll do this. So you'll follow step-by-step instructions to solve a problem. That's algorithm. It identifies what is to be done and the order in which it should be done. And then what is the task that I'd like to complete? And what steps will I follow to complete that particular task? That's your algorithm. But can every problem will be solved in the same fashion? I'll come to it. An algorithm is the starting point for writing a program. So even before you start writing a program, you should have your algorithm ready. Unless you don't have algorithm, there is no way you jump on to write a program. And people do that thing most of the time. They jump on to write a computer program without an algorithm. And that's a bad practice. Okay. I tell you, the best of the developers always scribble down an algorithm in your notepad. And once that algorithm they have thought over 10 times, then only they make an attempt to implement that algorithm. Programmers who are not very serious directly jump onto the keyboard and start coding the things, even for the most complex. And then they, over a period, by repeatedly, then they identify what is the issue. But the structured approach is to put it on a piece of paper, get it tested, and then implement it. So algorithm, we said, it is step-by-step instructions. So what exactly do you mean by instruction? Instructions are often expressed as something humans understand rather than something computers will understand. That means I'll say I'll read the data, I'll print the result, I'll add the values. So when I say print the result or I'll accept the data, that's not something that the computer will understand. To make it understand, you'll use appropriate command from your programming language. That's okay. But in algorithm, I'll only say I'll read the data. I'll add the first number with the second number. And you could write it in Hindi, you could write it in Marathi also. You could write it in English as well. We prefer English because then others will also understand. It's a global language, so we'll express our idea in English probably. So it's only about the algorithm that we create is not going to be supplied to the computer, and we're not going to ask a computer, this is the algorithm, you please develop a program based on it. Say Bhagyashree creates an algorithm and she gives it to Aditya saying, Dekho Aditya, I have thought about this, and you can write a program based on this idea. If Bhagyashree is the senior of Aditya, she's working on the same task, she comes with an idea. So she expresses an idea in such a fashion that Aditya can write a program based on it. So it's just in a format that we as humans can understand, not something that the computer can understand. It's not a computer program. It's for the programmer who's going to create a program based on this algorithm. When writing a program from pseudocode or from flowchart, we therefore decompose and translate these human instructions into sequence of computer instructions. So Bhagyashree says, I'll first read the first value, then I'll read the second value, then I'll add those two values, then I'll do this, then I'll do that, then I'll do that. Aditya, if he's a Python programmer, then to read the value, he'll call function input. To add the value, he'll use operator plus. To display the result, he'll use function called as print kind of thing. So you'll just translate that particular algorithm into a format that the machine understands, and that's coding. So if your algorithm is perfect, the code cannot go wrong. Because once you have created an algorithm and you got your algorithm tested, and I'm going to teach you technique where you can run your algorithm, believe me. You'll be wondering as to how, but there are fantastic tools which are available today through which you can test your algorithm. And I will be making use of that tool in this particular course. So you can run your algorithm, simple English you write and you run it. Simple English you write and you run it. So once you get the confidence, oh, this works, then write your C++, your Java, your Python, your C#, your .NET programs later, once you are confident that your idea works. Okay. So techniques have gone to such a level today that I have to change the way I teach. Earlier, we used to say, like, if I have to test an algorithm, we have to do it manually. Now there are tools which will test your algorithm, your idea. So get your idea tested first. Once you have tested your idea, then only write a program based on that particular idea to run the program. Okay, so that was algorithm. Any questions regarding what we discussed so far? Any query, any question that comes to your mind? Yes, anybody, any questions? Okay, I'm not going to trouble you much today. A brief, and we'll stop at a stage whose discussion we will be doing tomorrow. So 2 days of bit of theory, and then we'll go ahead and jump with the coding. Coding means the actual implementation. Yeah, somebody is asking some question.
The first PPT page. Sequence of this all this.
Didn't get you. First of means right at the beginning you said.
Yes. The four we have tried to make four
Four pillars of
four
this is
pillars.
what is.
Yes. Is there any sequence for this?
Definitely yes. What will come last will be our algorithm. Because once you have done the decomposition, divide a bigger problem to some problem, subproblem, or decomposition, abstraction, what needs to be represented, then afterwards your algorithms and pattern recognition will come. You identify the patterns and then you develop an algorithm to solve that particular this thing. So there will definitely be a sequence. Sequence will be most of the time what I have taken first decomposition, then pattern recognition, and then data representation, and then algorithm. That could be the sequence most of the time, but there is no such hard and fast rule. There will be sequence definitely when you build an algorithm. Why definitely sequence it? Okay. So why are we doing all these things? That's to solve a problem. There is a difficulty that somebody is facing, and we want to provide a solution so that the difficulty can be overcome. So solution is nothing but a technique of solving that particular difficulty, correct? A way to overcome the difficulty that somebody is facing. So what exactly is the problem? It's a state of difficulty that needs to be resolved. So some client is facing some difficulty. So that is a state of difficulty, and that we need to resolve. We have to come with a solution that will overcome that difficulty that is there. So what exactly is the problem? It's nothing but the state of difficulty. And it's a state of difficulty that needs to be resolved. That means we need to come with a solution for it. Problem exists where goal needs to be attained and there is uncertainty about the solution. So you have some objective in mind. I have to get this thing done. I have to reduce my time by so and so percentage, 50% less time it should take to do this computation. So there is a problem that exists. There's a goal that is to be attained. You have to bring down the time by 50%. But you are uncertain as to how can I achieve reduction in time to do the same task by 50%. How can I do it twice as fast as what I was doing earlier? So problem exists where goal needs to be attained. We have some goal. I need to get distinction in college. So if I have to have CGPA score of more than 9, so there is a goal, correct? But then the uncertainty as to how can I achieve that particular goal? So there exists a problem. And there is a problem, so there is a solution. There are step-by-step operations that you need to do so that you can achieve that particular goal. So you face problems in everyday life. It's not like only in programming we face problems. Everyday life, simple thing like, should I wear casual or formal today? Now, Shreya is attending the session for the first time. You were wondering, should I put on a t-shirt or should I put on a formal shirt when I go in front of the video, when I turn on my video? It's a simple thing. If you walk into your college today and you're wondering, oh, am I going to be a part of a mock interview? Oh, I should then not put on a t-shirt. I would rather put a full sleeve shirt kind of thing. So that's a small problem that is there in front of you because there is uncertainty that is involved. Okay, and there is a goal that needs to be achieved. Goal was, I should be in my best form for that activity. You're going to play cricket and you go in your blazer and other things. Now, that's not the way it should be. It will be more uncomfortable for you. So what should I wear? Casual or formal today? That depends upon what goal you would like to achieve. Okay, what is the objective that you have in front of you? Should I watch TV or should I go out for cinema? Okay, you want some entertainment. There's a goal to be achieved. There is uncertainty as to how we can do it. Uncertainty. Objective malum hai. I want to have some entertainment. but uncertainty hai. Arey, how can I achieve that? What's the career? That's the biggest thing that's troubling most of the student. What course should I take to make my career successful? So problems exist everywhere. Okay, what shoe should I wear? Every day morning, I also have a difficulty. What shoe should I wear? Then I decide upon which belt should I put on. So if I'm going to put on a brown shoe, then I make sure that I put on a belt which is also brown in color. If I'm going to wear black shoe, then I make sure that I put on the black belt as well. Okay, so which shoe I'm going to wear will be decided upon what color trouser that I put on, and that will decide which belt I put on. So there are things. It's not like whatever belt comes in my hand, I'll just put on that belt. Whichever shoe I see today, I'm just going to put on that shoe. So every day there are problems in front of us. And then we have to come with a solution and justification. Why did I do that? Everything needs decision as a solution to the problem. So there has to be a decision. If I tell you I'm going to wear a brown color shoes, I'll say, okay, I was wearing a light cream trouser today. So that brown color shoes look good. And if I'm going to wear a brown color shoes, my belt should also be of the same color. Okay, so there's a justification. There's a solution to that particular problem. I'm going to attend a meeting. Definitely, I'm not going to wear jeans and go. So why didn't I put that thing? Why did I do that? So everything needs a decision, and the decision is nothing but the solution to the problem. And you should be supposed to justify it. It's not just in computing, it's everywhere. So problems you face everywhere, but then sometimes you make a bad decision. So what's the cost of making a bad decision? What happens when you make a bad decision? Mika, what happens when a bad decision is made?
Probably the failure or a lot of confusion.
Okay, failure or confusion. Ankita, what happens when you make a wrong decision?
Sir, every bad decision has consequences.
What are the consequences there? That's the question. What is the consequences?
Like it depends on the decision we make, or
It
the situation, or any random situation which we are stuck in.
Can you generalize it? Sairam, what is the cost of making a bad decision?
Goal will not be achieved.
Goal will not be achieved. Okay. What else could happen? Shashwat? Shashwat is there. We ignored. We did not ask Shashwat. What's the cost of making a bad decision, Shashwat?
The work does not complete.
Come again. What did you say?
The work will not get complete, or
Work will not get
is-
completed.
face
Viraj,
issues.
You may mostly miss the deadline.
you may. All of you are telling me about may, what may happen. One thing that will definitely happen. Anybody? Rahul?
Wastage of time.
Wastage of time is definitely going to happen. Whatever else may happen or not. Who said wastage of time? It's Rahul? Who said?
It's Rohit.
Rohit said. Okay, Rohit said that. That's one resource, time. Okay, and time is directly proportional to cost.
Yes.
Some resource, some time. So anytime you make a bad decision, isn't it like waste of time and resources? Your
Yes.
efforts that you put in. Okay, water. Somebody said there is some consequences. Are these two not the consequences which you'll always face? Wastage of time and resources.
Yes,
Yes.
sir.
Yes.
Okay, so you have to be careful enough that you do not make bad decisions. So our attempt is how to have that guarantee that we do not make some bad decisions. Okay, so there are problems, and each kind of problem needs to be handled in a different way. There are different types of problems, and different types of problems need different way to handle it. But the technique that I'm going to discuss today, is it gonna, or in this particular course, will it make you confident about handling all the kind of problems? No, probably not. So what techniques I'm going to teach you will help you to handle only one set of problems, one kind of problems. What are those? Let's try and understand. So when you talk about problems, there are different types of problems, solutions that you may have. Problems do not always have straightforward solution. It may not be like a problem to answer. That doesn't happen. There are two types of solution to any problem. First is algorithmic solution. That is what we are going to focus in this particular course. And second is heuristic solutions. So there are two types of solutions here. I'm going to teach you only the first one, that is algorithmic solution. This is for some other day. Heuristic solutions are some other day. So what exactly is the difference between this algorithmic solution and heuristic solutions? Let's try and understand it. solutions that can be solved with a specific, with a series of action are called as algorithmic solution. So I'll do this, then I'll do that, then I'll do that, then I'll do that. And then if this is the case, I'll do this or I'll do that. So if there is series of actions that you take to solve a particular problem, and you're sure that if I do those things in that particular sequence, I can definitely solve that problem. If you can do that, we'll say it's an algorithmic solution. Once an alternative has been eliminated, the solution can be reached by completing the action steps. There are two different ways of doing it, but you decided this technique is better than the other one. So other one that you have selected, you just follow it one by one. You are guaranteed to have the right answer. Okay, you're guaranteed to have the solution which is working, or you will overcome your difficulty. The steps that you take, step-by-step operation that you perform to solve that particular problem is nothing but the algorithm that you have created. That's an algorithm that you have created. But then you may have more than one set of algorithm, but you eliminated one and you decided to focus on this idea. And when you write those options, steps, okay, I'll do this, then I'll do that. Then if this is the case, I'll do this or I'll do that. When you express it in that fashion, we say our algorithm is ready. That's algorithmic solution. Examples, we could take some. I'll give you an examples. But what are the heuristic solution? Now, suppose if I ask you, okay, let somebody help us. Suppose if I ask Rahul, if I ask you to make a cup of tea, how will you go about making a cup of tea?
There must be several steps.
That's what. Tell me the steps.
First, switch on gas.
Okay.
Then put some water inside that.
Yes.
No. The container which we want to make.
Vessel,
then some add some milk and tea powder, sugar.
It's like Rahul has never made tea. Look like to Chinese banaya Rahul ne.
Nice,
Okay, it's a
nice.
bad tea that you are making. Okay, bad tea. Okay. Prithviraj.
Take a vessel.
Okay.
Switch on the gas, put the vessel, pour in water.
The vessel. That means switch on the gas and put the vessel. Put it upside down. Put it.
No,
Put
no.
it means what to do.
Like place it on the gas or stove, whatever you have.
Okay.
And then pour water
Where? On your head?
inside the vessel.
Inside the vessel. Okay.
Yes, let it heat. Then put tea powder. And then let it boil for some minutes.
Okay. 10 minutes, 20 minutes, 1 hour, 180
Yeah.
minutes. Now look at this. You all are making assumptions, assuming that others know what is to be done. If you have to be a very good programmer, you have to be very specific as to I'll turn on that gas, heat that particular water up to this much time on a high flame or on a low flame, exactly for 5 minutes. So if you are writing programs, there are no assumptions that you should make about other person understanding it, because these instructions you're going to give it to computer, and computer unfortunately does not learn from experience in our normal cases. So you do not have an intelligent system where AI is involved. You have a dumb terminal machine, which is just going to do what you ask. So your instructions that you give have to be very, very specific as to what do I need to do. Now you all were smart enough. You at least gave me some set of idea, and that instructions I want you to change as a computer programmer. You have to be very specific as to what you say. Very, very specific. Minutest detail you have to specify. Okay. Say take a vessel. Now I take I want to make a cup of tea, and I take a vessel in which I could probably serve 100 people. So will that vessel work?
No.
No. So you have to be very specific. Take a vessel which can hold, say, 500 ml water, that big a vessel. Okay. So you have to be very specific. What is that vessel? What are you going to take? Should it be a cup? What kind of vessel it is? Should it be flat base? Should it be what exactly is the vessel that you're talking about? You have to be very specific. But you could still identify those things and give if I had asked Bhagyashree, probably she could have given you those steps much more detailed way, provided she has made a tea sometimes in her life. But now I want Kaustubh to give me an answer. Kaustubh, give me an answer. We both are playing chess, and I want you to give me a solution as to how will you win the chess game.
Sir,
Give me the step by step, like Rahul, somewhere he messed out. Prithviraj, Rahul made an attempt to give me a solution. Some way he has then given me a solution. Now you please tell me, we both are playing the chess, and you give me step by step operations that you do so that you win that game.
I cannot explain it.
You cannot explain. Shreyash,
So first I will analyze the situation.
tell me now, first step,
position-
second step, third step, बताओ ना क्या करोगे? Prithviraj gave the steps, Rahul gave the step, whatever the step they gave, but they gave the step. कि Rahul ने कहा पानी डालेंगे, he mixed everything separately and then he went on to boil. But there was a recipe that he gave. It was his way of making tea, specialty. Prithviraj has his own way of making tea. You tell me your way of winning the game against me.
So first I will take water in a vessel.
Hey, tea का खत्म.
Then
आपका
just-
क्वेश्चन अलग है. We are both are playing chess. You tell me what
Okay.
steps will you follow to win that chess game.
So first I will analyze the situation. What are the placements of the pawns, and
That's the first step. Second,
second, then I will think of a way to eliminate most of your pawns.
is it possible in one step you will eliminate most of the pawns?
Not in one step, sir, but
तो एक step एक
one
समय
by
एक step
one.
ना. तो Prithviraj could have said, I'll take material and make the tea. नहीं चलेगा ना. You are trying to break down step by step operations. You tell me what is the first step, what is the second step, and give me an assurance. If I follow these 10 steps, I'll win, sir.
It's difficult to explain.
Ashish,
Sir, first we will analyze the position of the pawns or pieces of opponents and
let's say it's the beginning of the game. Nothing has moved. You are making the first move.
Sir, win also depend upon the opponent's turn.
Correct. To give me the steps now. Your goal is to win the game.
Sir, without input of opponent, we can't give the solution.
So will you not make the first move also?
We will make the first move.
You will make
But
the first move.
if we are the white piece, so we will make
The first move. And what would be the second move be? Tell me. These are the difficult kind of problems that we are going to face. The first problem that I gave where Rahul and Prithviraj made an attempt, that was very simple because that was algorithm solution. And believe me, we'll start our journey with programming only by solving such algorithms, not by making tea or coffee. Don't we think about it, but similar kind of things where you can give step-by-step instructions and you can solve the problem. The other problems that we face are the one which we call them as heuristic solutions, where pertaining to trial and error method for problem solving used when algorithmic approach is impractical. So the technique that I'm going to teach you right now will not be in a position to solve the problem where you're going to win the chess game. Probably not. That is not the technique that I'm going to teach you right now. But that does not mean you will not be a confident developer. That techniques can be learned later. Currently, what we are going to focus is on algorithmic approach. But where algorithmic approach is impractical, you need to think about heuristic solutions. Employing a self-learning approach to a solution of a problem is known as heuristic solution. Self-learning approach. That means, okay, mark that word self-learning. Self-learning approach to a solution of a problem is known as heuristic solution, where your solution is so smart that it learns. That means when I moved I made certain move and then you responded in such a way to that situation, you failed, you lost the game. That's a learning. That program should remember what made you win the situation and what situations you lost. And that knowledge it should use when it makes the next move or when it plays the next game. You know what I'm trying to say? So more the games that your program plays, the program starts learning from the past experience. It could have won, it could have been lost. But then it comes with ideas. The program comes with an idea on its own so that it makes the better move the next time and its chances of winning increases as more and more games are played. Because the program or the machine, the solution is self-learning, it is learning on experience. Like when you play games, when you play chess games, 10 games, you definitely learn from it. And next time you can handle that particular situation in a much better way. Likewise, how about your programs learning on their own? And that is nothing but what we know today This trial and learning approach is nothing but AI, what we talk about, artificial intelligence, where the things learn on their own. We create models. You must have heard this term. We create a model, we train the model. Have you heard this term, training the model? So training model is what? Giving them enough of information, similar kind of data, they process that, and then they start recognizing the pattern. They understand, oh, if this is the case, this is how I have to solve that particular problem. This solution requires reasoning built on knowledge and experience and a process of trial and error. Mark these words, huh?
Sir,
So, yes, please.
sir, by this solution, do you mean that if we make a certain AI in a higher end game, and if we attack that AI, it will attack us in return. So, is it?
It will either win or it will lose, but whatever happens, it will learn from their experience. So tomorrow, what made it win, it remembers. What made it lose, that also it remembers, so that it will make the better move next time. So your system is learning from the past experiences, the data that you have supplied to it. Data is nothing but on your chessboard, what was the scenario? All of them talked about, oh, there is a scenario, we'll analyze. What analysis this made, and then based on the analysis, whatever decision that they took, what move they had to make, did that move for that situation result into success or failure? So that analysis that will make, and it will remember that experience. It will use that knowledge for the next time the game is being played. So these AI things are becoming more and more smarter, more we use them. Okay, the solution that requires reasoning built on knowledge and experience and a process of trial and error. Solution that cannot be reached through a direct step by step are called as heuristic. So it's not like algorithm where I do this, then I'll do that, then I'll do that. It's not like Rahul and Prithviraj making cup of tea or coffee where they give the step of instructions to get that work done. Yeah,
Sir, sir, do you want to say that it will react to your feedback?
Obviously, yes, it will react to the feedback, but the most important thing is whatever was the outcome of that feedback, outcome of that reaction, it memorizes. It keeps that thing as an experience. It uses that experience when it has to give the reaction next time. Getting my point?
Yes, sir.
It will react to your action, but what happened because of that, it will remember. And that information it will use next time when it faces the same situation. So these are heuristic solutions, and that require some additional, techniques for us. This could be learned later. Focus on algorithm solution first. So algorithm solution, making a cup of coffee, finding the largest of the three numbers. Heuristic solution, how to buy the best stock, shares or equity. Very difficult decision. How to play a chess. Very difficult decision. What will make you do that? So you, based on the past history of the stock, how it is performing, what happened, which month, how it performs. There are so many factors on which it will be decided. So those heuristic solutions are actually very difficult to build. But today we have techniques with AI being emerging, machines becoming more powerful. And you have these powerful machines which can work on huge data set to build that experience. Whatever experience that you may gain in, say, I have an experience of, say, 20 years of programming. We can give the same experience to your program within few days. Why? Because it works very fast. You can pass that much of data to that particular machine. So it can learn what probably I have learned in 40 years or 20 years. That the machine could learn in few days. That could happen. Okay. But those solutions, the technique of building those solutions is difficult, or not difficult, different. But once you are through with algorithm solution, then you can confidently make a move towards going ahead with heuristic solutions as well. Understood the difference between these two types of solutions, everybody?
Sir,
yes,
you said it will learn if you once interact with it. But what if you have not, you have not interacted or you have not given a feedback? What will be the response for the first time?
It could be some response whose outcome may not be the desired one. Ankita, we'll be doing it for another 5 minutes and we'll stop. It will not be the desired one. And it may or may not be the desired one. Whatever it is, it will learn. Whatever response it will give first time, what happened because of that, that will add to its experience. So mark that word as experience. That's very important. It will make some move based on its own judgment, and they will remember what happened because of that. It will never forget. It will learn normally we say your computers do not learn from experience. Here is the age where the machines, the programs are learning from experience. So world has changed today. Machines start learning from experience. So when we talk about problem solving with computers, the one that we are going to approach, computers are built to deal with algorithm solutions. What we are going to do today, we have computers which deals with heuristic solutions as well. But we are going to focus on these algorithm solutions. People are better than computers at developing heuristic solutions. We are better than making the judgment than what machines will do. We are far more smarter than the machines. The field of computers that deal with heuristic type of problems is called as artificial intelligence. So if you are into AI, no, cyber security. Somebody was into AI as well. So if you are into Ankita, are you into AI?
No, sir. Normal CS.
Yes. So somebody.
Sir, it was Pooja. It was Pooja Korkile. She's
It was
not there.
Pooja. Okay, she's not there right now. So the field of computers that deal with heuristic type of problems are called as artificial AI. What is buzzword today? Artificial intelligence enable a computer to do things like build its own knowledge bank and speak with human language. So it builds its own knowledge bank based on experiences, how much of operations that it does. As a result, computers' problem-solving abilities are similar to those of human beings. They start working like humans. Although we are still smarter than the machines, but they start thinking like humans, and they build their experience based on their past things that has happened with it. So that's about what we plan to discuss today. Tomorrow when we meet, we'll talk about what are the difficulties that we face while we are designing a solution and what are the steps that one should follow to overcome that particular difficulty. Now we'll just have a quick feedback round, what you have understood, what you have learned today for today. Aditya, what was your learning for today? Oh, we cannot hear Aditya. There's something wrong. Ashish, what are the learning?
Sir, the algorithm solution is, and the second type of solution, heuristic solution. That
What do you understood out of it?
Sir, basically algorithm solution is a step-by-step process, and when you do that step, you know that after doing this step, the certain type of result will be there. But in a heuristic solution, there is a trial and error method.
Okay.
And where algorithm approach is impractical.
Thing is that solution learns from experience.
Yes.
Okay, that's something which is very important. Okay, Rohit.
So today we started with the introduction with the programming and problem solving.
What was your learning? Your takeaway?
Yes.
Okay. What
So
I felt
my
like, okay.
So my takeaway was the most of us, or I will tell about my experience. The syntax error usually what scared me, or like the syntax was more like a complexity for me. But as you told me that the syntax that the computational part is only like about 30%, but 70% is about how you can learn. But also that is also one type of complexity that whenever I see any problem, the main thing was from where should I start, and that's the first thing you told us, that don't worry about that thing. You are going to guide us very well with the help of 3: sequence, selection, and iteration, and with the help of 4 pillars. As I'm learning the language, I know the power of the language, but how to use that power with the help of our skills, that I got to learn.
Good. Ashish.
So I got to know about the basic constructs and 4 pillars of computational thinking.
What are the 4 pillars?
Yes, sir.
What were the 4 pillars?
Sorry, sir, I can't hear you.
What were the 4 pillars?
Decomposition, pattern recognition, abstraction, and algorithm.
But did you really understand the purpose of them? As to
Yes, sir.
why is it important for you to understand that?
Yes, sir.
Okay. Sanjay?
the 4 pillars of computational thinking, and that and how to solve problem.
Sairam,
Sir, heuristic solution.
heuristic solutions. What was new over there? What you
We in day to day we just hear about AI and ML, but we don't know that what kind of it is.
what kind
So
of-
generally we work in algorithmic, so it's just assume that something like that will be there only. But
Correct.
just by using that chess example, we got to know that it's a different type of solution altogether.
Very correct. It's a different type of solution that requires different treatment.
Yes.
Okay. Most of the time, when you design systems, it could be like the regular algorithmic problems.
Yeah.
But believe me, what you learn in algorithmic problem, even to develop heuristic solution, that will play a role.
Okay.
Just that how to train it, how to create that model, that will be different.
Yes.
But then these techniques that we'll use will also be used to develop an heuristic solution. But for that, there is some models that we have to create. So once you master this algorithmic technique, you can use that knowledge even to build heuristic solutions.
Yes.
But the technology will be different. Bhagyashree?
Algorithm and heuristic solutions.
Okay. Kaustubh?
Sir, the most important learning was data abstraction. So I knew the term, sir, but I did not know the exact definition. So figuring out what's the important stuff or what's the important details or characteristics of a problem and filtering out those which are not important to us. Or
Very correct.
that was the most important.
Clarity. That clarity is something which is very important.
Yes.
Okay. Who is Rahul?
For the basic construct to expressing ideas means sequence, selection, and iteration for new form, and the solutions that are heuristic solution and algorithmic solutions.
Okay. Amongst us, we have one youngest fellow, Shashwat.
Yes, sir.
What is your learning?
Sir, we learn about how a big problem can be solved by using the 4 pillars. By first is decomposition, where we can break into small parts and easily sub problems. Then we can second is the pattern recognition, where we can decompose the problem and find patterns among the sub problems.
Apply the techniques that we had used on some other problem again over here. Reapply. Okay.
And then the data representation and abstraction, which determines the characteristics of problems that are important. And then the algorithm to write it step by step instruction to how to solve it.
Is your audio back?
Yes, sir. Am I audible?
Yes.
Yes, sir. So my today's learning was that like we have to consider a few steps before applying, before making any program. We directly jump upon the algorithms. So first of all, we have to think about the decomposition of that problem, and we have to recognize the patterns and that 4 pillars which we have talked about in this lecture. So that are the most important factors before considering any big problem, that we have to first decompose it and recognize it patterns and abstractions and then algorithm. Then we have to jump. Lastly, we have to jump upon the algorithms.
Okay. We'll look into the final steps as well as we go ahead. Viraj?
Sir, the 4 pillars. Sir, I wanted to ask that that decomposition term, is it specific in IT something?
No, it's everywhere.
No, sir, because when I heard that first time, being from civil, I thought it is like recycle or something. So that thing was new for me.
Okay.
And other thing was heuristic solutions. It was very relatable to me. So I found that a bit different and unique, those 2 terms.
Okay. Who is remaining? Ankita?
Yes, sir.
Your learning for today.
Yes, sir. So we started with the introduction to programming and problem solving, in which first we saw the computational thinking, which is the approach to solve problems using different concepts. And in the computational thinking,
I want your learning. What was something that you learned? You felt like, okay, this is what I understood today.
for everything.
What is something that you thought like you did not know and now there is a clarity?
Decomposition, pattern recognition, and data representation and abstraction.
Okay, data representation. That was that brought you some clarity.
Yes, sir.
Monica?
This very first thing I have learned that how to look at the problem
Okay, that's
instead
very
of
important.
instead of going to direct to the solution, we have to follow some steps by using 4 pillars of 4 pillars.
How to use them, I'll
Like-
be discussing later. But then there are 4 pillars that we should always have in our mind. ये हमारे पास है. Okay.
And one more thing is heuristic solutions, means about AI. We can they
AI.
are using AI.
Okay. Who else is remaining? Who did not give the feedback today? Who is given?
I am remaining.
Tell me, yes.
The 4 pillars of computational thinking: decomposition, pattern recognition, abstraction, and algorithm. And heuristic solutions, that was new for me.
Heuristic solution was new for you.
Yes.
Okay. So with that note, we'll stop here today. We meet tomorrow and we continue with our further discussion. Tomorrow we'll be more specific about what steps we should follow so that we can actually solve any algorithm solution that problem that is there for us. And once we are done that, okay, I'll go through all the steps and I'll also take you through something called as HDLC, Software Development Lifecycle. Something techniques that Sairam said they use, sometimes they just make passing reference to it. What are those techniques which are there, which are used in the industry? I'll make a passing reference to them so that you are aware of those terms. So if you hear about somebody says waterfall, it should not be like you only think about Zoke falls or something like that. So there is something like waterfall model, there is something like Scrum, there is something like Kanban, there is something like XP. So I'll make you familiar with the terms that you and me as a developer should be aware of. And you will definitely come across those terms. You like it, you don't like it, you have to work with them. So it's better that you get to know about those techniques as well. So tomorrow's session will be on algorithms. Day after tomorrow, I'll talk about this same concepts. I'll explain more technical terms, or I could take it later. In between, we'll start off with the tools that that we'll be using to express our ideas that are there. So thank you all for the session today. See you tomorrow, same time. Take care. Love you all. Bye-bye.